Today is the start of a YouTube series designed to introduce people to options. The goal of this course is to provide you with just enough knowledge to where you can convince someone else that you know at least a little bit about options. It's also to give you a good foundation for you to study maybe specific topics in the course that we didn't go too far into, but you'll have enough of a baseline to be able to study further on your own. You won't remember everything in this course, and there are probably some things that you'll never use in this course, but the general idea is that at the end of the day, most of these concepts will blend together and that they'll be intuitive. And the idea is not that you really need to memorize anything, but if you just look at it and then you just think about it, you'll arrive to the correct answer. And then lastly, we're going to augment this course with real world option data that you can, access on my GitHub and apply your own knowledge and apply our own techniques that we've learned in the course to real world data. So to truly understand options, you do need quite a bit of math and a lot more math than what's really going to be listed below. But to make this course as accessible as possible, we should be able to get by with just basic calculus and statistics. And if there's anything, specific that you don't understand, you can always chat GPT the concept and just to fill in the gaps. So now we'll just start off with the first lesson. So there are a lot of ways in which people can introduce options. Some people will go straight into the most technical details and into stochastic calculus, or they'll go into binomial models. But we're going to take kind of a different approach. We're going to take a more microeconomic approach. So the idea in this module is we're just going to kind of forget about the math and just talk about this. So let's start off with the simple definition. What is an option? An option is a contract which conveys to its owner, the holder, the right but not obligation to buy or sell a specific quantity of an underlying asset at a price on or before a specified date, depending on the style of option. Now, this might seem like a rather specific definition, why would someone use this? But it turns out that in history, people have been using these options for quite a while. So let's go back to our history. So, according to Aristotle, there is this Greek mathematician called Miltiades, and on a certain occasion, he basically predicted that the olive harvest would be larger than usual, and that presumably there would be a lot of people trying to use olive presses. So, what he did is he acquired the right to use a number of olive presses the following spring. And so, when the spring came and the harvest was due, it was a lot larger than most people expected, and he exercised his options, got a bunch of olive presses, and then rented them out. And so he made a lot of money because uh, he was able to secure these olive presses in advance for a lot cheaper than what he was renting it out to. Uh, Now, in truth, this is more of a legend, but this is just kind of the idea. So we're going to kind of underline some unique attributes of an option. So for an option, there is an underlying asset. So the asset is based on something like a stock, or in this case, an olive press. And there is some strike price at which the option can be exercised. Then there's an exercise right, like what the option holder can do, buy or sell olive presses. There's an expiration date, which is the last date to use the option, such as the end of next harvest season. And then there's something called a premium, which is basically the cost to purchase this option. So let's start off with just a simple example. Suppose I have an orange. I offer my friend the right, but not obligation to buy my orange in exactly 3 weeks from now. How much should my friend pay for this option? Or what would be the premium? And so before we get into like kind of like super technical terminology, let's just kind of brainstorm a rational way to value this option. So if I were to buy someone's orange in 3 weeks, the first thing I would want to know. So hopefully you've thought of what state the orange will be in 3 weeks from now. After all, if you're buying an orange in 3 weeks, it's important to kind of think about what the orange would be in 3 weeks. So here are some possible outcomes. The orange could be rotted in 3 weeks. The orange could be somewhat unchanged if it were stored in a freezer. And presumably, I would be very displeased if the orange was rotten, uh, but I'd be very happy if maybe the option was if the orange was healthy and was stored in a freezer. So mathematically, we can call these sets of outcomes a sample space. And in a sense, these are the states of the world for which the orange can exist in 3 weeks from now, and that's going to be a prime uh, consideration for how much I'm going to pay. So what's something else that you would really want to know before you price this option? Well, I would probably want to know a probability for each of these events. So for whatever reason, let's assign to both outcomes a 50% chance of each of them occurring. So the act of assigning numbers to this sample space is called a probability measure. And it just so happens I measured these outcomes as being equally likely. But someone else in the room could have certainly come up with different assignments or a different measure. So what's another thing we should consider in valuing this option? The value in each state. So it's kind of obvious, but we should consider what it means to us to emotionally possess an orange in the given states. And we can call this emotion utility. So if I possess an orange in a particular state that makes me happy, we can say that the utility is positive, some number. And if it makes me sadder or annoyed, then the utility is negative, or perhaps zero. And then let's also not forget that paying any money up front for this contract means we tie up capital until the option expires. And so the initial loss of wealth is surely a negative utility as well. Everyone can have different utilities. They can assign, larger numbers or smaller numbers to any of these outcomes. And we can just call this preferences. So a fairly rational model, in my opinion, would be why don't we find the average utility across all of these outcomes? And we can do this by weighing the utility gained from each possible outcome by the probability of it occurring. In other words, an expected value. And I would buy this option uh, as long as the average utility, this average utility, is greater than the utility of parting ways with my cash. So at some point, if we keep raising the price, the utility of not having my cash is going to outweigh the utility of buying the option, and then I will just refuse the option.